theorem on the rank and nullity, that if A is m by n matrix, then rank of A is number of leading variables in the general solution of the system Ax is equal to 0, and nullity of A is the number of parameters in the general solution of Ax is equal to 0. So don't remember this remark. It is not this theorem. So we know that the rank of the matrix is the basis dimension of row space or column space, and nullity of A is what? Is the dimension of null space or the solution space of the system X is equal to 0. So example is find the basis and rank of A given by this matrix. We have to reduce A to row echelon form because we have to find the rank of the matrix. So how we can find the rank of the matrix? Either by reducing the matrix to by finding the dimension of row space or column space. So in order to find the rank of dimension and basis of row space, we have to reduce this matrix to echelon form. And in order to find the dimension and basis of column space, we have to reduce this matrix to reduced row echelon form. So here we have to find the rank. So it's depend on you. So how we can find the rank? We will find the dimension of the row space of the A, and in order to find the basis and dimension of row space of A, we have to reduce this matrix to row echelon form or echelon form. So consider the matrix, and by successive row transformation, that is reduce this 3, 2 and this 1 are equal to 0, and the remaining calculation we have, this is the this is the row echelon form, not reduced row echelon form. This is just row echelon form or echelon form. This is an echelon form, a row echelon form of the matrix A by applying the row transformation. So this is not unique. This depends on your calculation. So this answer is not unique, this row echelon form, but the number of non-zero rows in this are 2, and therefore this answer is unique. So the non-zero rows of this matrix are what? This is the first row, 1, comma 2, comma minus 1, comma. That is the first row as a first vector, and the second row as a second vector. There are 2 non-zero rows, and therefore basis for row space of A is the, write in the curly bracket these 2 vectors. Write in curly bracket, that is the set. Basis for row space of A is the set of these 2 vectors, and therefore the dimension of row space is 2. Dimension of row space is 2 because the basis contains 2 vectors, and therefore dimension of row space is 2, of A is 2, and therefore rank of A is 2. Therefore we say rank of A is 2. So find the basis and rank of the matrix A. So rank of the matrix, right here one more sentence, that rank of A is 2 because the dimension of row space of A is 2. And then we can also find the nullity of the matrix. So by using this theorem, dimension theorem or rank nullity theorem, that rank of A plus nullity of A is equal to number of columns in that matrix. So use that theorem, rank of A plus nullity of A is equal to number of columns in A. So rank of A is 2, then nullity of A we have to find, and number of columns are 4, 1, 2, 3 and 4. There are 4 columns, and so nullity of A is 4 minus 2, that is 2. So if we find the rank, then we have the nullity, and if we find nullity, then we have the rank by using this theorem. So in order to find rank and nullity, we will find only either rank or nullity of the matrix. Then by using dimension theorem or rank nullity theorem, we'll find the another one. So find the number of parameters in the general solution. Ax is equal to 0 if A is 5/7 matrix of rank 3. That is where to find number of parameters in the system, and the number of parameters in the system is the nullity of A. That is indirectly we have to rank is given, and we have to find the nullity. So use the rank nullity theorem, that rank of A plus rank nullity of A is equal to number of variables, number of columns in the matrix. So this A is of order 5/7, means there are 5 rows and 7 columns. So use that theorem, that rank of A plus nullity of A is equal to 7. And so we have to find the rank of A. N is 7, that is number of columns are 7, and rank of A is 3. We have to find nullity of A. So nullity of A is 7 minus 3. That is the substitute rank of A as 3, and the nullity of A is equal to 7, means nullity of A is 7 minus 3. By using like this, we are given a rank, we have to find nullity. Number of columns are 7, so 7 minus 3, that is 4, is the nullity of the matrix. And nullity of the matrix is nothing but the number of parameters in the general solution. Okay, so what is the number of leading variables means what, and number of parameters means what. So if we take the system, here is the system. So what are the number of parameters and what are the number of variables in the system. See, this is the example. So this is the system. After this is the system, this is the system. So after reducing the system to echelon form, we have again two equations, and then we have to assign three unknowns, because there are two equations and we have to yes, this is the matrix. After converting the matrix to echelon form, we have this is the echelon form, and after rewriting we have this system. So this is the system. In this system there are two equations and five unknowns. So the difference between these two is what? 3 minus 2 is equal to 2. The 5 minus 2 is equal to 3. That is, we have to assign three unknowns. We have to assign three unknowns, either x3, x4, x5, and these are called parameters. So we have to assign three unknowns, means parameters are 3, and number of leading variables are what? X1 and x2, that is 2. Okay, so out of these 5, 3 are parameters and number of leading variables are 2. So what is the leading variables and what is mean of the number of variables? So number of variables means and the number of variables and number of leading leading coefficients. Okay, so this is number of the rank of A in this matrix. If you observe the rank of here, we assign three variables, because there are two equations and we have to assign three variables. If you observe this example, so what is number of leading variables are 2, and the number of parameters are 3, and therefore here three variables are assigned, and therefore if you observe, nullity of A is 3. That is, nullity of A is the number of number of parameters in the system Ax is equal to 0. And what is the rank of the matrix? Rank of matrix is 2. For this matrix, there are two non-zero rows, so rank of A is 2. Rank of A is 2. What is rank? Is number of leading variables, and then parameters means after rewriting the system, we have to assign three variables, means there are three parameters, and the parameters means the nullity of the matrix, and the leading variables means the rank of the matrix. So this is the another form of the definition of rank of the matrix. And so these types are examples are important for MCQ type questions. So find the number of parameters in the general solution X is equal to 0, means find the number of parameters. The number of parameters means this. The number of parameters means nullity of A. Okay, so that is where we have to find the number of parameters in the general solution X is equal to 0, means we have to find the nullity of A, and the rank of A is 3. So rank of A is given and nullity of. Then next question is again the find rank of this matrix of order 5 by 7. That is, there are 7 columns, for which Ax is equal to 0 has two-dimensional solution space. Two-dimensional solution space. That is, nullity is given now. Nullity is 2, and we have to find the rank. So this is the answer. The matrix A has nullity 2, because number of independent two-dimensional solution space. That is, dimension of solution space is 2. And the dimension of solution space of system X is equal to 0 is nothing but the dimension of null space of the matrix X, the system X is equal to 0. And the dimension of null space is the nullity of the matrix. So nullity of the matrix is 2, and we have to find the rank. So the theorem is rank of A plus nullity of A is equal to number of columns, that is 7. And so rank of A is 7 minus 2, nullity of A. And therefore it is 5 by using the rank nullity theorem. So if A is any matrix, then rank of A and rank of A transpose both are same. So find the basis for null space of this matrix, null space. That is, we have to find the indirectly nullity of the matrix, nullity, that is null space. So null space of A is the solution space of the homogeneous system X is equal to 0. Null space of the matrix A is the solution space of the homogeneous system Ax is equal to 0. So what is the Ax is equal to 0? That is, this is A, and X is the matrix of order like X, column matrix x1, x2, x3, x4, x5, because there are 5 columns, is equal to 0, 0, 0, 0. So we write the system in that system in equation form, then it is x1 plus 4x2 plus 5x3 plus 6x4 plus 9x5 is equal to 0. Similarly, we have the second equation, 3x1 plus minus 2x2 plus x3 plus 4x4 minus x5 is equal to 0. Similarly, third equation, fourth equation. So we have to find the solution space of this system. So this is the system, and we have to find its solution. So we have to find first solution of this system. That is, we have to find the x1 values of x1, x2, x3, x4, x5, and we have to reduce the we have to apply the Gauss elimination method. That is, form the augmented matrix. That is our coefficient matrix. So right, this is the augmented matrix, coefficient matrix. Right here, 0, 0, 0, 0. One more column, 0, 0, 0. Or no need of that writing. We either reduce the in the form of homogeneous system, we consider as an augmented matrix or coefficient matrix, and we have to reduce the matrix to echelon form. So we had to reduce this matrix to echelon form. So this is actually not coefficient matrix. This is coefficient matrix, and we have to reduce this matrix to echelon form. That is, we have to reduce this 3 minus 1 to 0 first. Here it is 1. So the operations are R2 minus 3R1, then R3 plus R1, and R4 minus 2R1, or R4 plus in bracket minus 2R1. So after that, we have 0, 0, 0 at this place. And so the remaining entries are also changed. Now we have to reduce this minus 14 to 1. So the operation is, transformation is minus 1 by 14 R2. So we have 1, 1, 1, 1 at this place, and it is 2. Then we have to reduce this below elements to 0. So the operations are next. In next step, we have to apply R3 plus minus 4 R2, because here is 1. So 4 minus 4 is 0. Then in order to reduce this minus 5 to 0, the operation is R4 plus 5 R2. And then we have all the element entries in the third row and fourth row are 0. And this is an echelon form. This is an echelon form, row echelon form. In order to obtain reduced row echelon form, we have to reduce this element 4 to 0. So operation is R1 minus 4 R2. By using this one, we have to reduce this equal to 0. So this is an reduced row echelon form. Reduced row echelon form. So we can either reduce the matrix to echelon form or reduce row echelon form. Okay. So then rewrite the equation. So corresponding system is what? X1 plus x3 plus 2x4 plus x5 is equal to 0. Or use this matrix to rewrite the equation. And the second equation is x2 plus x3 plus x4 plus 2x5 is equal to 0. And therefore, there are 2 equations and 3 unknowns, 5 unknowns. There are 2 equations and 5 unknowns. So we have to assign 5 minus 2, that is 3 unknowns. So we assign x2 as R, x4 as S, and x5 as t, and then the last equation implies x2 is minus x3 minus x4 minus 2x5. That is, we have x2 as minus r minus s minus 2t, and from equation number 1 we have x1 is minus x3 minus 2x4 minus x5, that is minus r minus 2s minus t. Okay, and so we have to assign three unknowns, means these are the parameters. There are three parameters and two leading coefficients. So two leading variables. So by using this, what is the rank and what is the nullity? The number of leading variables are 2 in this example, and the number of parameters are 3. And also rank of A is 2 and the nullity of A is 3. There are 3 parameters and 2 leading variables. Because we are assigned 3 unknowns. So these 3 are parameters. There are 3 parameters, and these x1 and x2 are the 2 leading variables. And so rank of A is 2 and nullity of A is 3. So don't use that definition. We have to reduce this matrix, this solution in the matrix form. Then as addition of, then write R, take R common, and then we have, don't write this step, directly write this R plus S plus T. So what are the coefficient of R? Minus 1, 1, 0, 0. And then what are the coefficient of S? Minus 2, minus 1, 0, 1, 0. So right here. And the coefficient of T, minus 1, minus 2, then 0, 0, 1. Okay. And so the basis for the solution space for this system, so that is solution space of the basis for, this is the basis for null space, basis for null space of the matrix, and this is actually the solutions basis for solution space of the system X is equal to 0 is nothing but the basis for null space of the matrix A is equal to B, and write this as a first vector minus 1, 1, 0, 0. This as the second vector, this as the third vector, as a in the form of row, in the form of vertical position, horizontal position. It is now, it is in the column form, we write in the row form. So this is the basis for null space. This is the basis for null space of A, this B. Okay, and the dimension of null space of this null space is what? Dimension of null space is 3, because there are 3 vectors in the basis of null space, and therefore nullity of the matrix is 3, and the rank of the matrix is 2, because if you observe, this is echelon form, so it contains 2 non-zero rows, and so the rank of the matrix is 2. And nullity of the matrix is 5. Find the basis of subspace of R raised to 4 spanned by these vectors, 3 vectors. That is the space spanned by the given vectors is the row space of this matrix. So write this first as a vector as a first row, the second vector as second row, and the third vector as third row, and find the basis for row space of this matrix A is nothing but the basis for subspace spanned by these 3 vectors. So just form the matrix as its rows are these 3 vectors, and then find the basis for row space of this matrix. And in order to find the basis for row space of this matrix, we have to reduce this matrix to echelon form, row echelon form. So we have to reduce these 2, and these 2 are equal to 0. So R2 minus 2R1, R3 minus 2R1. So we have this matrix. Then we have to reduce this minus 2 to 1. So minus 1 half R2 as the application. So we have 0, 1, minus 5, 2. Then we have to reduce this minus 3 to 0. So the application is, transformation is R3 plus 3R2. And we have this. Then we have to reduce this minus 4 to 1. So the operation is minus 1 by 4 R3. So we have this 20 by 4 is minus 5. 20 by minus 5 is minus 4 is minus 5. That is multiply by 1 by minus 1 by 4, minus 1 by 4. So we have this, and this is an row echelon form. Okay, and there are 2 non-zero, 3 non-zero rows. This is the non-zero, this is non-zero, this is non-zero. So denote the first non-zero row as a v1 vector v1, second non-zero row v2, v3. So these three uh, forms the basis for row space of the matrix A, row space of the matrix A, and consequently form a basis for space spanned by the given three vectors. So by the space, the basis for space, suppose space spanned by these three vectors is the set contains these three vectors v1, v2, v3. This set form the set of these three vectors, and it is the basis for subspace spanned by the given three vectors. Okay, and so its dimension is 3. Find the basis of subspace spanned by these four vectors. So form the matrix A as a row. These vectors are row of the matrix. So we have to find the subspace spanned by these four vectors, means we have to find the row space of the matrix, this matrix A. So reduce this matrix to echelon form. Here is what we have to reduce this 4, 5, and 2 R2 0. So operation are R2 minus 4 R1, R3 minus 5 R1, R4 minus 2 R1. And so after application, we have this. We have to reduce this minus 7 to 1. So minus 1 by 7 R2 as the application. We have this, and then reduce this 2 to 0, minus 7 and minus 4. So while reducing this minus 7 and minus 4 to 0, we have all the entries in the third row and fourth row are equal to 0. And so this is that echelon form. This is the row echelon form. And so there are two non-zero rows. What are that? 1, comma 2 minus 1, and the second row as a second vector. And so this is the two element set is the basis for row space of A, that is the basis for subspace of R3 spanned by these three vectors, four vectors. Write that sentence. Find the basis for column space of A consisting entirely columns of A, entire columns of A. So we have to find the basis for column space of this matrix. So reduce this matrix to reduced row echelon form, because we have to find the basis for column space of A. So consider the matrix A and reduce the matrix to reduced row echelon form. So in order to reduce the matrix to reduced row echelon form, we have to reduce this minus 2 and 3 to 0. So operations are R2 minus R2 plus 2 R1 and R4 minus 3 R1. So we have this matrix now after this row transformations. Then we have to reduce this minus 1 to plus 1. Then operation is transformation minus 1 into R2. So we have this. And then we have to reduce this minus 3 to 0. So operation is R3 plus 2 R1, R3 plus 3 R1. R3 plus 3 R1. Okay. So we have, this is the matrix again after this transformation, R3 plus 3 R1. Okay. We have this, don't write this, R3 plus 3 R1, R2, not R1, R3 plus 3 R2. By using this one, we have to reduce this. Then we have to reduce this minus 5 to 1, minus 5 to 1. So minus 1 by 5 R3. So we have, this is the matrix. Then we reduce this minus 13 to 0. So operation is R4 plus 13 R4 R3. By using this one, we have to reduce this minus 13 to 0. So we have, this is, and this is the actually row echelon form. We have to reduce this matrix to reduced row echelon form. So what is the difference? This is an row echelon form. We have to reduce this matrix to reduced row echelon form in order to find the basis for column space of E. So we have to reduce the elements of the columns that contains leading 1 to 0, except that one. So this is the column containing leading 1. So if you observe, this is 1 and remaining element are 0. But and this column contains leading 1 and this column contains leading 1. What are that? First, second, and fourth number column. So I have to reduce this 2 to 0. This 2 to 0. So what is the application? R1 minus 2 R2. We have 0 at that place. R1 minus 2 R1, 2 R2. R1 minus 2 R2, not R3. And now we have to reduce this minus 3 to 0. Next step, R2 plus R2 plus 3 R1, R2, R3 here, R3, right? R3, 3 R3. So we have this, and then this we have to reduce this matrix to 0. So R1 minus 2 R3. So one by one apply all these applications. We have this is the reduced row echelon form of the matrix. So we have to reduce this 2 to 0, then this 2 and minus 3 to 0. So one by one, first reduce this 2 to 0, or first reduce this 2 and minus 3 to 0. So we have this, by using these two operations, we have these 2 are 0. Then we have to reduce this 2 to 0. So what is the operation? R1 minus 2 R2. After this we have this. So apply these two application at a time, that reduce this 2 and minus 3 one time 0, and this 2 next time 0. So this is that reduced row echelon form, because if you have observe the first column, second column and third column contains leading one, these are the leading one, and the remaining elements of the that in that columns are 0. So this is the reduced row echelon form. So denote these three vectors 1 0 0, these three columns, first column, second column and fourth column. This forms the basis for this matrix R, and we have to write the basis for column space of A. So the corresponding column number 1, column number 2 and column number 4, these three columns, that is C1 1 minus 2 0 3, right, as a first column as a first vector, second column as second vector, and fourth column as third vector, C4 as this. And so this forms the basis for a column space of A. Right, in the set form, right, in these three vectors in the set, and that set is a basis for column space of A, and therefore this set contains three vectors, and therefore dimension of column space of A is 3, and so we can say that rank of A is 3. Find rank and nullity of the matrix. So these are some examples. So we'll see these examples in the next lecture. Find rank and nullity. So this is actually repetition of the previous topic, that rank and nullity means we have to find the basis and dimension of null space and row space or column space. So we'll see the remaining example in the next lecture.